messages send. We're in. What's up, C. Grover? Day to you. Nice to see you, my friend. Let's go. Coffee. Right. Good morning. Day. Happy Saturday. Time it is for you. Thanks for everyone who's watching. All right. Browser one. Yes. Welcome. Good day. Good morning. Try to get rid of my keys. All right. If you are new, first of all, thanks for watching. If you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I usually stream at this time each week around 10 a.m. Central Time, working on some stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more at circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. Today, however, we're picking up where we left off last week. I'm working on the same thing that I worked on last Saturday, which is actually over in Blinka land. Blinka is the compatibility layer for CircuitPython. So this allows CircuitPython to run on single board computers like Raspberry Pis. It allows you to run code on these devices that is, CircuitPython code. It uses the CircuitPython APIs, which of course, some of which are different than the normal Python APIs, the CPython APIs, because CPython itself doesn't have the ability directly to interact with I/O pins and do all the stuff that CircuitPython does. So Blinka is the compatibility layer that lets you run code that was written for CircuitPython on actual CPython on Raspberry Pis and other single board computers. It is also a compatibility layer for MicroPython microcontrollers as well. If you run MicroPython on your device, Blinka is going to allow you to use CircuitPython code even though you're inside MicroPython. But the single board computer part of it is more what we are dealing with today on the stream, and then I have actually taken it a bit further than that. I'm not even really using Blinka on a single board computer. I'm just using it on my standard desktop Linux computer PC. So, and I actually have gotten some screenshots over the week of people running this on Windows as well. So there are folks using this on other platforms too. So Blinka is intended for these single board computers, but on this stream and what I worked on last week, I am actually just using it straight up on my desktop PC, Linux PC in my case. So diving right in, we need to... Actually, I want to start over in PyGame Display. So PyGame Display, if you didn't catch last week and you don't know, PyGame Display is my library which allows you to use Blinka Displayio. Blinka Displayio is just the Displayio module of Blinka, the thing I was just talking about. PyGame Display lets you use Blinka Displayio on PCs, also like I was just saying. On desktop computers with PyGame, the Python library that allows you, it's like a game framework. In this case, we're not using it to make a game, we're just using it because it happens to have very convenient canvas rendering APIs. So we can get our pixel data from Blinka Displayio and we can get it into a window on the computer with PyGame. That's what it's used for here. And I want to start actually looking with this Hug report this week. Huge thanks to BablockB, who has done some work to try to bring auto refresh support back. So one of the things I talked about last week was that auto refresh was no longer supported. And BablockB has done some work to bring it back. It is still limited in its functionality. It's got a separate thread, as I understand it, but the actual refresh is now kind of happening, I think, from check quit, which you are intended to call every iteration of your main loop, or at least very frequently anyway, when you use this PyGame display thing. This is the main place where the PyGame display differs from just a standard CircuitPython display. This is not a concept that exists in CircuitPython. And it looks like what's going on now is auto refresh can be set to true, and it runs its thread, and it does its sort of like computation. It's getting pixels ready in the background, and then in the foreground, it does the actual send it to PyGame so that it will actually be shown. If I understand right. It has to be called by the main thread. Event loop. Okay, so it has a redraw event. So basically, does check quit then just call event loop? No, but check quit is calling. Okay, let me look at this over here. More natural for me without the code breaks. Let's say GPR list, and let's repo again. Oh, okay, I'm in the right repo, but my terminal is in the wrong spot. Tricky. List. There we go. Check out 24. Ooh, I wonder if I just hey, I don't know. I wonder if I just broke some of those by checking that out when I had changes to those. Last thing. We don't want all of these. Okay, so. But that's changes here. I think I added prints. Okay. Let's get back to main actual. I think that's installed with -E, so it should just have the latest version inside of PyGame display now. We are on auto refresh, and I want to compare that against the old main. I think origin get remote rename origin. Compare this with main. Okay, so we do not have threading. We do not have data classes. I guess that's covered in some other way, or maybe it wasn't used. So then this is getting bus display now. Display event is in event custom type. Display event code refresh 1. Redraw events, window shown, exposed, moved, resized. So these I'm less clear on the intention of all of these, because I don't. I'm gonna switch back to main real fast and just run one of these. Kind of took a while. Anyway. Maybe there's a sleep in it? So all of that stuff is like different thing now. I can keep, or if I can keep that. Some of this is like moved, resized, size changed, maximized, restored. And all of this is added. And so I switched back to main, which means I don't have any of that stuff currently. But like mine can move just fine. I don't have a maximize button. Maybe this will add a maximize button. I could double click. That doesn't actually do anything. Yeah, maximize doesn't work here. Maybe this would add maximize, but I can resize. Like, I don't think the bottom. Oh, maybe I can't resize. Okay. I thought I could before, but that's like a window manager problem. Okay, so maybe that stuff is all gonna enable this. For some reason, I actually did think all of this just worked before, but I guess not. Although there is a case to be made, like, do we really want that, right? Like, I'm not sure this should be resizable because you have initialized it at a size, right? Like, the code that we ran has initialized the display, in this case at 640 by 480, which is how big it is here as far as I get it, as far as I understand it. And so if you were to resize this, one of two things has to happen. Either the stuff that, like, we either keep the size you declared here at its real size in a smaller box in the middle, assuming that you made it bigger, or we try to stretch it, but then it no longer matches this. Like, you kind of have this potentially distorted aspect ratio thing going on, which is not really a concept with the physical displays that Blinka Displayio really thinks you're working with. We'll try it. Let's see what it does if we switch back. I'm curious. A refresh. Okay, so we'll be able to maybe run that again. Okay, one thing that's very interesting is now it's allowing 2 instances, which I don't like it used to do. I don't know, because that still doesn't let me resize. Movement is fine. Minimize is fine. I guess I didn't do minimize a minute ago. Let me... Oh, my X doesn't work, though. Oh, it does, but it takes a while. Weird. Okay. I don't get what all of this stuff is for, because it doesn't make that much of a difference in the behavior to me. So I went back to main just now to run this. I should start running a different one. I don't know why this one, well, that one went a bit faster. So minimize is fine, right? I can minimize this. I can bring it back. It's no problem. It still renders. I guess I'm not changing anything. I don't know if refresh is broken. Fairly clear, I guess, what the problem with minimize and maximize currently are that need this new stuff to handle. Let's get back to looking at the code too. Because, like, I don't necessarily know, like, does this code need... Are these for callbacks? I mean, events? Seems like these will be callbacks kind of things. Let me switch This makes a little more sense in my head if the new one is on the right, so I'm actually going to switch back and then compare again. That's going to put the new stuff on the right. Really matter, but it just makes more sense in my head. Or it did not do that? Did it not do that? Is this... I guess because we extend this and it's already true there, doesn't have to be put here. It will be on Quargs if it gets passed, and it will default to true because we extended bus display. This says native frames per second, last refresh, refresh pending. It used to have these things, which are now gone. So some of this stuff I had either commented out or left in from when it was not working, the threading stuff. So comment out the prints, that's fine. Auto refresh again so we don't... Okay, that was... that's kind of funny. So this was accepting false here, but also ignoring it and just passing false up to super anyway. So even if you had passed true, it wouldn't work. I thought I actually maybe... Did I make it raise? No, I guess not. I don't know. This comment, so I commented this out when it wasn't working. That's been removed. Size, white space, loading. Yeah, we can comment that out. That's fine. Yeah, I mean, we could delete that. We just start the PyGame refresh. So this is old stuff. I'm pretty sure this was not really used, but it was kind of like I left the stuff here in case it was important to getting auto refresh back. Invalid name. One of the things I would like to do is maybe get rid of pylon and move to rough. I know that I'm going to do that right now. So this is what? This is in fresh area. Okay, those were commented out anyway. Fresh display now exists. And it calls super and then flip. Then it sets the refresh time. It sets this boolean to false. Refresh itself is gone. I guess probably because of... I presume that bus display dot refresh, when you call it, probably calls underscore refresh display. So by implementing this, we make it so that we don't need a explicit implementation of this. That's my guess. We're not all the way down. Perhaps it shows back up later, but that is my guess from here. So release used to be doing these things and isn't anymore. Those might have been old, I guess. But then check quit now has delay. If event type equals quit. So it used to say if it equals quit. Now it says if it is a Displayio event. So this is in check quit and it says PyGame event.get. Okay, so we used to only care about the quit one. That's the only one that we did anything for. Now we, if it's a Displayio event and the code is code refresh, then call refresh display. Elif it is quit or window close. Unclear to me what the difference between those would be, but it seems like they have two now. Perhaps they had two before and I didn't realize. Then set PyGame screen to none. Dang, I'm not sure what that does exactly. Maybe that's like a GC. It's gonna release some resources or something. I'm not sure. Event type. So then if it's PyGame redraw events, then force a refresh even if auto refresh is false. Interesting. So will this, but I mean, this doesn't check auto refresh. But it does flip these, and that implies that something is going to check the time to see if it's actually time to refresh or not. And then this would override it, even if it, well, no, this would override auto refresh. I don't know. That's weird. I'm not sure what the, I'm not sure I understand the difference between this branch of logic and this branch of logic, which both end up just calling refresh displays. Display, singular. PyGame redraw. Okay, so these are Displayio events. These are PyGame events. So I guess this would mean like resize. Or in some context, I guess minimize, maximize, although it's not, for me, that's not requiring this in order to work, but maybe there's some situation where it would. Okay, then sleep for the delay time. Event loop takes a delay. Where does event loop get called from? Interval. Okay, none of these were commented before in the doc string. So this is a little bit odd to me. So we inside check quit, we handle PyGame events. But then inside of event loop, we also have another loop that's handling PyGame events. And I'm not sure I understand why it's handled that way in both places. So background core will call this method in a background thread to refresh. This PyGame has to be updated from the main thread. We override this from the parent class and only put an event on the PyGame event queue and let the main thread handle that refresh. Main thread sets this to none during quit. Okay, I do remember seeing that. That was the thing I said about GC or whatever. That's not actually GC, it's this. So this was all commented out, but now it says if auto refresh and if not a refresh is pending, so we're not pending a refresh and we do have auto refresh and the time, and basically it's time to refresh, I assume is what that logic is, then create an event or a Displayio event and post it. Refresh pending true, and then sleep. So, does this get called from somewhere? Is this a magic name for PyGame, or? Not get called anywhere. But this says has to be called by the main thread. So, in my mind, this would have to be called from check quit. So I wonder if one or the other of these is left over. It almost feels like this stuff got refactored into this function, but it didn't get removed from here. Like, to me, it almost feels like this should be commented and this should call a self dot event loop and pass all the stuff that it needs. So I don't know how you would get all that stuff. All the delay we have. I guess this is gonna just get callbacks magically. Let's check. faster? That's not ideal. Simple test doesn't work. I think the order of the importing? So this imports Displayio first and Blinka Displayio PyGame display last. I wonder if the other way around. Unhappy now. Yeah, I mean, this is not getting any callbacks. Get the minimize, maximize, I'll quit. One thing that I do think is a little bit problematic is like the time here. Like I already clicked X a while ago. That took like several more seconds before it actually quit. Is there a sleep in this? I mean, there's no sleep here. Let's put a print inside check quit and see how fast we're calling check quit. Yeah, we never saw this at all either. I guess it would eventually it would get stuck in the while true. I think we never actually got to there. No. I do think they mentioned in the PR something about that maybe. But yeah, that's never printing. It seems like that doesn't get used. How fast does this get called? It should be fast. It is not. It's actually really slow. Huh. So technically this is the auto refresh true, but I also called refresh on it before. Mess it up? So if I auto refresh false, is that any faster? But shouldn't render this time, I think, because there's no refresh. It is way faster. It must be. I mean, in this case, I would argue it's broken because it shouldn't be showing. I think, right? Because This is false, and I have never called refresh. So why were we able to see it? True, right? The only place where refresh is here. Okay, let's see if we can figure out the problem with this. So this, when it tries to import PyGame display, tries to import bus display, which tries to import display core, tries to import bus display. Well, so this is in Displayio init. It imports bus display. Bus display is trying to import display core, but that ends up importing init. Ends up making that fail. So is it? I don't really understand why the other one works, and I'm guessing it's just this. If we put this the other way around, then it's okay? So one thing is, I'm pretty sure there's a like first refresh that there shouldn't be. Because we are again on auto refresh false, and we do not currently have any uncommented refresh statements. There's two and they're both commented out, but yet we still saw the stuff get drawn. But it is only the first stuff because we don't see the color changing of the text. I mean, I don't like this is way slower than the manual refresh. I'm not sure I see all the way the benefit, I guess. I mean, it makes the API the same, but well, we need to fix the auto refresh part, I guess. I don't get why it's so much slower though. Something is weird about the auto refresh still, I believe, because the manual refresh was able to run way faster than this. Still pretty slow, honestly. Still slower, I think, than the microcontroller even does. But faster than this. I mean, this is almost like... This is getting close to 1 change per second. I think it's a little faster than that. Like, maybe it's 0.75 seconds or somewhere in there. But if we use the manual refresh one, that's like 3 or 4 or 5 changes per second. Okay. So I think my feedback is as follows. Is event loop used? Do we need this at all? Let me try just commenting it out, actually. I mean, I put prints in there, and the prints are not happening, so feel like it should be safe to assume it's not getting called. Maybe somehow print statements from this get consumed or something? So let's try to just remove it and see what breaks, if anything. One is the manual refresh. It does seem like it hangs on the first color a little bit longer. Maybe there's an extra time sleep, I'm not sure. But that's basically just doing the exact same thing. All of that seems fine. So then what about the auto? In the wrong file again. Like, in... Yeah, this all still runs. And it still runs at the same speed. I don't think this is used. I mean, does that happen with main? If that happens with main, then it's not a problem with this PR. Okay, so let's pull this back and pull this back because that's going to make checking out easier. So if this is false and this is not called, shouldn't see any. Okay, I believe that's correct. And then if we were to refresh once, we should see things. Yeah. We got black first and then refresh. So the refresh we could kind of even see before it happened and then after it happened. Nope. So the so the first manual refresh is broken in my opinion because it shouldn't happen without you calling it because it's manual. Um, I've also noticed that the auto refresh equals true seems to cause the main loop of code.py to run, main loop of user code to run considerably slower. Like 1 to 2 iterations per second instead of, I mean, I think it's more like 4 or 5 at least. I didn't put any measuring on it. Maybe we'll just say 3 to 4. 3 to 5, 3 to 4, instead of 3 to 4 iterations per second. Manual refresh, calling refresh loop. A simple test script in this repo makes this easy to see. With auto refresh through, color only changes about once per second. But if you manual refresh color text, it's many second. Curious about why main loop slowed down so much. Auto. And then the other one, the last thing that I noticed was about the imports. So if you just go to REPL and import this, I think it will crash because of circular imports? No. When did we get circular imports? Not with this here? On main. Oh, there is a check actually for auto refresh. Nice. A new one. This branch is a circular port. Go to REPL, just import this library. Raises this exception. I think if you put the port Displayio first, and then this, it will succeed. That might be a problem with Blinka Displayio, honestly, though, right? Because all PyGame display did is import bus display. Right. And so that shouldn't really, like, the fact that that goes circular, I think indicates a problem in Blinka Displayio more so than this branch of PyGame display. We could test that by just importing bus display in the REPL. Yeah. Import bus display is his exception. Oh, for a second I was like, what is all of this? But that's because I'm in the REPL, which is inside JetBrains. Okay. So that's kind of where that is at. I think that I want to try one more thing in main branch. So if I just go back to main, what if we, like, wouldn't it be faster? Wouldn't it, like, render faster without that, like, the way the main loop got so slow? Like, in my head, if the core solution is refresh from check quit and I guess main has this already. Wasn't getting used here either. Okay. Maybe that was in the old one. But there were some changes to it in this one, and I think it definitely doesn't need to change if it's not getting used. But couldn't we just be like, if self.auto refresh, then self.refresh? And then that would be the same API wise, but presumably go faster since it's going faster. We need to fix it. Boy, that would have been. Oh. Well, actually, that should still be false. We want to do it this way, I think. So that's true. Turn that off. Okay, so auto refresh is true, which means basically that display check quit is going to refresh for us. Ah, that is not working. Oh, fair enough. So for the output from the program, but I haven't run it yet. Auto refresh is false. Did I not set it to true? But then we supered it to false. I think by doing this, we made it false, but I also think by making it true, it's going to break something. True now. Breaking anything, but it also is not drawing, so it's breaking something, I guess. I think what we really want is to that false super close, but basically kind of make it true. This one pretty much a different one, I guess. Always false. I guess that also exists probably on super. This one is like, is it still a bit slower, right? It's like in between. Very bizarre. I would not expect that to be any different than just having having that be false. False, false, false. Well, we probably slowed it down by printing, actually. Yeah, we probably slowed it down by printing. Totally, because that's a bit slower now as well. The exit is faster. Nice. Maybe it's not slower. I don't know. Maybe I'm overestimating how much faster it was before. I mean, it felt faster a little bit ago. Let me take the print back out. See if that makes much of a difference. I think that there still may be some, like, I don't know if dirty regions are getting handled or whatever. Like, we might be drawing every pixel, every frame, even when it hasn't changed. Okay, yeah, I think that's back to the speed that it was before. Like 3 or 4 per second. The blues, I think there's more blues than some of the other colors, and it's making it seem like it doesn't change because my eyes can't actually pick out some of the differences in there. But the rest of these are like quarter notes kind of thing, basically. Um, yeah, so I don't necessarily, if the core solution is effectively just refresh from check quit, I'm not sure I see a need for all of the other stuff instead of just adding a refresh check like this, but what I will do is refresh from check quit. Yeah, I started doing rough. Just like randomly did that and then never, I don't, like, there's no rough pommel. I mean, to be fair, I don't really want what's here. Like, I do want the rough one, but I don't, it doesn't need to be committed into this random branch because it's not actually going to work, I don't think. And it's unrelated to the refresh stuff. I will also say, for I understand the need for the resize, minimize. Things. Maybe it's a thing where like on Windows you can do all of that stuff, but on Linux you can't? I don't know. Okay. That's cool. I kind of have an idea of where that stands. I kind of have an idea of the sort of high level way that auto refresh can be supported, which is that essentially it can't really have its own thread doing its own thing. Instead, it kind of pretty much just needs to refresh from inside of check quit. All right, back to bitmaptools, I think now, which now that file is gone because no, it's not. It's right here. It just doesn't have all that stuff in the beginning of it. Okay. Let's run this. What is this going to do? Not going to work because we don't have bitmaptools because I need to go to the proper branch of Blinka Displayio. All right, I'll be right back. Okay. Not installed with -E. Weird. Okay. Anyway. All right, read into. So this one was. I did not do this on stream. I think last week, where did we leave off? I think I had only done like the shapes, like rectangle, which is called fill region maybe, or something like that. Circle, polygon line. Did I do blit maybe last week as well? Since then, I have also done rotozoom and read into and arrayblit. Yeah, those are the new ones, I think, that I did not do on stream, but those now are implemented. And then where I'm actually picking up is I need to test, next we need to test, what is it called? Alpha blend, which it took me a little while to understand what alpha blend was supposed to do, and I ended up down a different rabbit hole about some weird error message stuff in the core. But I do now understand what alpha blend does, and I do also have alpha blend function implemented with the best guess that ChatGPT wanted to give me. I think that I had started changing this. So that should actually say is none instead of what it does now. but it needs this too. And you actually do need to spell everything correctly, it turns out. There we go. Let's leave that alone for now. So basically what I did is I gave ChatGPT the C function, and I said, could you please implement a Python version of this? And this is what it came up with. But I haven't tested it yet because I didn't really know what this function did all the way, so I can't really test it without knowing what it's expected to do. Earlier this week, though, I did some tests on the core on a PyPortal, and I did figure out what it does, how it works, and how to use it. Makes it so that I can, in fact, now test it here a little bit better. By a little bit better, I mean test it at all. So we are going to gank that code off of my PyPortal, and then I am going to start with not this one, but instead just this. Okay, so pretty much what is going on with this code here is it's making two bitmaps that are the same size, which is important. They are RGB bitmaps. They are not indexed. They're RGB. They're 16-bit color. In the first bitmap, we're filling in the color blue, it looks like right now, by using the color converter to convert that to 16 bits, 565. We got our second bitmap right here. In the second bitmap, there's basically a grid of gray squares that are 8 pixels by 8 pixels. So it's just a big chunky grid of different shades of gray. And then when those two things get blended together, we end up with a grid of different shades of blue because we have blended blue with different shades of gray. Missing a positional argument blend mode. Yeah, it looks like we didn't pass that. It's fair. Let's give it a default. We're in the wrong. Where's Blinka display? So is there a default in CircuitPython? None equals blend mode dot normal. I guess none. I mean, wouldn't it be better to just default to normal? But we do. Okay, it's getting used here. So the possible modes are what? Screen and normal. Okay, so we need to make those. Those are like constants that we don't have currently. And those are just bitmaptools dot blend mode. We need a class blend mode. No. Yes. Yes, we need a class called blend mode, and it needs to have, but you don't have to init it. How do you make constants? If I just put normal equals something, let's look in the core maybe. No, blend. What was the other one? Screen. I don't know. I guess we could just make them... okay, I have no idea if that actually works or not. We put normal there, and then when we are here, we should be checking against those constants. Also elif, because more explicit. Let's give that a try. Index 33, so I think that means I have wrong. I think that maybe my bitmap is too big, my destination bitmap. I'm pretty sure your destination bitmap needs to also match, yeah. I think your destination bitmap needs to match, well, it needs to be 16-bit color as well. I'm pretty sure it has to be the same size. I was getting at there. I never actually did spit it out, but so this is 32 by 32, because in fact this is kind of basically the weird rabbit hole I went down in the core. Was when these don't match, the core tries to print an error message and fails for some reason and prints a different, less specific error message. Okay, so that ran. It did not crash. But we don't see anything. Auto refresh is false. We did refresh here, so thing definitely went wrong. We still did not pass blend mode, but blend mode was normal. Okay, so what I'm going to do now is make this match the code that is on the PyPortal currently, because I had switched it up a bit to try some other things. A bunch of this is duplicated, but okay, so we got, I don't have the camera set up, but I got a nice like 4x4 grid of different shades of blue, essentially, because of the way that it alpha blended with the different shades of gray. So our Python implementation is not working. Not a terribly huge surprise, truthfully. Go see if we can't figure out what's going on here. So for one thing, why would we be clamping to this? This doesn't make a whole lot of sense to me. Clamp says min value, max value. I don't know why we would be doing that. I don't think we want that. Not our color space. Interestingly, that is looking more like 16-bit. Wait, did I not just change these? Hold on, did I not? I just changed these. Why are these not changed? Is there a different spot that used those? Oh. Okay. Oh, well, but then we should have still... I think that's still not going to work. I'm suspicious of that clamp. I don't know why we shouldn't really be clamping the pixels to 256, I don't think. Because this is going pixel equals some values, and then ultimately, I don't know what these are. Skip source index. We're not using any skip source indexes. I don't think. Okay, so actually that was in the L8. I think the clamp was in the L8. Yeah. Which is grayscale, I'm pretty sure. Not positive, but I don't really know. And it's not what I'm using. I do know that much, I'm pretty sure. So this is actually just going dest equals pixel, so that feels like it should be pretty much fine. One thing that is a bit odd is this is saying if both of these, then do all this stuff. Elif just this, do that stuff. Elif that, do that stuff. Else do that, and then it's also just doing this again at the end. So if I'm understanding right, that's just doubling up setting pixels, which shouldn't like... Oh, no, it's not. No, it's not. This is backwards. I'm dyslexic. That's saying pixel from. That's getting pixel from dest. Okay, so if none of those are true, then we just take the pixel that's in the dest. I mean, couldn't we just not do anything in that case? I guess it doesn't matter. Okay, what are we actually setting these to? Print hex pixel hex hex pixel. Should, well, 565. It's maybe we'll be able to tell what's going on. You'd have to convert those back to... You have to convert those back to 888 for them to really mean anything to me. But I do think it's working pretty much fine-ish, sort of, maybe. But it's just not ending. It's just not showing on the screen. Did I mess up the tile grid? So tile grid is... I know what the problem is. I know what the problem is. I did not copy over all the right code. So our bitmap, our destination bitmap, is now 16-bit. When we put it to a tile grid, we need to not just try to use a palette. That is... Honestly, I'm surprised that didn't, like, cause an error of some sort. Like an exception, I mean, not a... Like, obviously we have a logic error because it's not doing what expecting at first, but... Okay, here we go. Now we run that, and I think he still... It's not working correctly, but it is showing some blue, which is closer the right direction. What is our scale set to right now? So I'm on scale 16. I think that's too big, actually. I should be on scale 4. Do that. Okay. That's kind of, sort of similar to what it's supposed to look like. We're getting closer, certainly. It shouldn't really be striped like that. I'm guessing I have done something else wrong still. Is this used? Seem like that's used. That says +3, but really the code's doing +8. Should it be doing +7? It should be doing +7. Okay, let's remove this from the equation for a second, and I would like to show the source bitmaps. Source tile grid. Actually, thing. All right, so that is source bitmap 1. Should be blue. All right, that's our problem. It is not blue. Then if I take this exact same thing into here, turn that off, and I put this, and I go main group append that, and I run this on the PyPortal, I in fact get a solid square of blue. Okay. So fill doesn't seem to work correctly, seemingly. Either fill or color converter. Color converter is basically just doing math. Let me find a 565 color. 565 color picker. Blue. Is that the 565 value? 565 value. Guess so. So if we just, and I mean, theoretically, this should be like literally doing the exact same thing. It's just that color converter doing the math that web page is doing for us. Okay, yeah, so we get the exact same thing. So fill not working for some reason. Why would that be? Does anything else in here use fill? Fill 3. That was working fine, I think. We can't really test it anymore because, well, here we can. Well, but it's the same size as this one. So maybe fill doesn't work for 16-bit? If it's read-only, dirty area, iron range bits per value word. To be honest, I don't really know what that's doing. For iron range stride bitmap height data word. Okay. Magic going on. Not understand. So for I in range 32 over bits per value. Do word thing equals value and bit mask. Let me try seeing if our friend he wants to be able to tell us. Filling a bitmap. I didn't put the code. Yes, I didn't put the code. I know, I'm sorry. Okay, yes, I tried to put the code and then I failed. GPT thinks I'm an idiot. Fair enough. You can see what's happening, allegedly. It's correctly computing 32-bit word repeated copies, writing the word repeatedly into data, which I assume is the underlying uint32 representing. What's wrong? You're filling the bitmap by writing the same word into every 32-bit word of memory. That only works if the number of bits per pixel evenly divides by 32. If the pixels line up perfectly with the 32-bit words, that's not the case. You'll get strange patterns like that. Properly fill, you want to loop over each pixel instead of individual. My assumption is that this might be basically how the core is implemented. Or similar to how the core is implemented, since it's obviously not the exact same. Their behaviors differ. Yeah, this is basically all the same. All the same logic. Okay, so what if I say have this C implementation of the game function? This one does work correctly. Fill the entire bitmap. Can you tell why this saves the original Python code this time? How the bitmap data is stored and interpreted. Self.data is a pointer to a block of raw memory. Self.stride is in words. Self.stride times height is the total number of 32-bit words. Data writes data into memory. Bit packing is handled correctly when the memory is later interpreted. In Python, self.data is probably a Python level structure like a byte array, memory view, or whatever. Validate that while we're Memory view. Is none. Well, that's convenient. The only place where this gets called, data is none, is a writable buffer, it says. Data array. I'm guessing that's probably a.array. It's not I, but it's L. You need to make sure that self data is array I. Right is in words, not pixels or bytes. Personally, I kind of just like the 2 for loops better. But it looks like this might be, well, it's going to be this. It's probably going to be the same iterations, right? Or is it? I mean, it's writing multiple pixels at a time, I feel like, right? Well, it depends on how many bits are per pixel, I suppose. What difference did? Only works if it's per words with the works. I'll be the judge. Is there a difference though? I don't actually see. See a difference. Oh, here we go. Okay, total words. No, because that's just multiplying. That's not gonna be different. That's the same code. I think maybe we're just gonna go to the for loops one. I mean, let's verify, but which, like, it's telling me it only works under these conditions, so I guess we must not be under those conditions. I just like the XY one. I mean, it's kind of nice, I suppose, when Blinka has the same logic as the core, but not necessarily when the logic in the core is being tricky with the way that the memory is packed. I don't know, I can see pros and cons, I guess, but did I mean get pixel? No. Pixel or set pixel, I'm last couple of times that I asked it stuff, I actually told it how to get and set pixels in the bitmap, and it was able to do it for me, but it saved anyway, basically, because I don't ever log in. I guess they'll let me not log in. Okay, we have a solid blue square. That's good. That is what we want. So let's turn that back off. Let's turn this back on. Bam. That is what I see on the PyPortal 2, pretty much. I will say the colors are like kind of different, sort of, but I don't think that that's like functionally different. I think that that's a different display, right? The PyPortal has its display. It has its light levels and its limitations and its viewing angles and all of its stuff. This here is a giant TV with its own light levels and limitations and viewing angles and stuff. To my eye, in this lighting condition that I have it in right now, the one on the PyPortal My eye looks slightly brighter. Each shade of blue looks slightly brighter than the one on here. But I don't think it's actually wrong. I think it's just two different displays rendering how they render. Okay. That, I do think, though, is what Alpha Blend is supposed to do. So I think that's good now. It's not necessarily like a super robust test or anything. It's just one thing. You could maybe tweak it so like we should be able to just change this to green or like let's say teal for now. Oops. Okay, I saved that on the PyPortal, and then I also tried to run it, and then PyPortal was like, or I mean PyCharm was like, running this doesn't do. Oh, right, I changed this. Yeah, there we go. That one's. We could do that with any color. And we could make it more interesting as well by making source 2 have something that's not just a grid of gray squares, but it does basically make this testable, which is all I was after. Okay. Alpha Blend is working. Assuming, well, Alpha Blend is working and fill needs to be fixed. But that's not related to bitmaptools or Alpha Blend. In fact, we could, I guess I could like remove that from the equation entirely by using one of our other handy bitmaptools functions. In fact, do an extra test here. Fill region. I mean, arguably, there's no need for both of these things to exist, truthfully. Well, that's not true. Fill region can do a subsection of the bitmap. Yeah. Fill region, we want bitmap 1, want the region, I assume, and just have to pass all of those. Probably we need to come back and add logic, because I think it's probably supposed to be like, if you omit those, then it will be the bitmap's width and height or something, which doesn't appear to be currently set up. Further, that we're typing some of the code. It doesn't like this for some reason. Do we need to say dest bitmap? Oh, well, we need to call it the actual variable name. There. There we go. And then we could do this without the, just to make sure that I'm tracking what I've just done here. We could do this without the fixed version of. I like, in my mind, this logic is just basically better though, essentially. This matches the core, and if it worked, it would be nice to have the logic be the exact same as the core. But if it doesn't work, which it doesn't, there would have to be more logic here added to account for the whatever is actually different, if it's the stride or the words or whatever, some of the stuff that the Jippity was trying to tell me, I'm sure. I'm sure that stuff is related to what's different, essentially. Theoretically, more logic could be added to here to handle it, but this is just way simpler in my mind. And we don't really care about the speed or the memory layout or anything here. On CPython, I think simple is probably better. We can run this now and it should just work the same because we're not using fill anymore. Array. Still filling this, but we are immediately overriding it by alpha blending other stuff into the exact same rectangle that filled. Theoretically, we actually were getting the broken fill, but then we were just overriding every pixel anyway. So matter. Okay. And then I'm pretty sure that actually the last function that is not implemented yet is dither. And I will be upfront in that dither is another one, much like alpha blend, which I just had never used before. Actually, read into I had never used before either, or arrayBlit. All of those, I had to do the same thing where I started out on the PyPortal figuring out like what the function does before I even wrote one character of code in here. And I guess that's probably where we want to start for dither also. So dither, it has another one of these things which are these constants. So let's make those class, what is it? Dither mode, dither algorithm. And that gets a Atkinson and a Floyd Steinberg. Same thing as this, bitmaptools.dither algorithm.Atkinson Floyd Stenberg. I always want to say Floyd Steinberg, but there's no I there, huh? It's Floyd Stenberg. I don't know if these technically are strings. CircuitPython seems to be printing it as a string, but that could be like a 2-string. Or bitmaptools, dither algorithm dot send that and Floyd Steinberg. We'll just go with that. Just trying to make sure I didn't typo anything. Looks like I got it all correct. Okay, so then you give it a destination bitmap, you give it a source bitmap, you give it a source color space, you give it a dither algorithm, and then it does its thing. For the destination bitmap, it must have a value count of 2 to 16 bits. Max. The stored values are 0. The stored values are 0 and the maximum pixel value. Stored values are 0 and the maximum pixel value. I don't know what that means. Source bitmap that contains graphical region to be dithered, it must have a value count. So this one has to be 16-bit. This one can be less. The color space of the image would be nice if it said maybe the source image. I assume that means the source image, because those are just 16-bit color spaces. And then the dither algorithm. Okay, let's go to the PyPortal. And I guess let's try just dithering the gray checkerboard thing into the destination bitmap for now and see if that does anything that's visible or not. So destination is bitmap. Source, wasn't that next? That says bitmap with 2 P's. Did that come from the code? Is it bitmap with 2 P's in the code? Some of that comes from the code, I think. But it's not, but it's only the docstring code, I guess, in the core, right? Here it's only 1. Okay. That could be fixed though. 2 P's there. But it is source, so we're gonna say source actually 2 because that's the one with the gray things in it. That just completely changed what I'm doing. Next is the color space. So that is 565. Algorithm will use Atkinson by default. So let's just leave that alone and see if this does anything. Okay, it did something. Again, I don't have the camera set up, so probably is not going to be very good, but it drew some little white boxes, basically. Kind of more packed in towards the bottom right and less packed in towards the top left, which kind of tracks with the top left is darker, the bottom right is lighter. What Dither is doing is basically conveying color with pixel, how closely together the pixels are packed, essentially. Let's try Floyd. That one, same kind of deal, looks slightly different. The squares are in a different spot. There's more of them. They're packed tighter at the bottom. That's basically it. And then theoretically we could do that for like real stuff, like we did that with maybe Blinka. Yeah, okay. So with Blinka, maybe that's the one we should test. With Blinka we get doesn't really focus, but we kind of, you can see we get like a sort of data matrixy Blinka there. It actually looks pretty cool. That over to here. Theoretically, that should just show Blinka. Nice, okay. Does Dither always take it to black and white? Yeah, I think quantize is the other thing. In my head, I have gotten quantize and dither tied together because when I learned about them, I basically learned about them at the same time. And I was using them both, it turns out, for the thing that I was doing. So we will give this the old ChatGPT try and see how the one that it spits out does. I don't know if it matters, but I feel like it kind of makes sense to get a new one, which will let me do without. Really need to pop that up every time. I have this C function from the Circuit Python core. Can you please write a Python implementation of the same function? Can omit anything related to dirty area handling. We need to tell it how to set pixels. So it's using fill row. This feels like more bit packing stuff, right? This kind of feels like it's doing a similar... Are all of these usages in dither, or are there some that aren't? Like they're all in dither. So is this actually fill row, like fill all the pixels of the row? Or is this actually fill row, like fill row with the dither logic applied? Hmm. And then we have basically the same problem for right pixels. So right pixels is saying bitmap, a y value, and then a pointer to booleans. Okay. So it's going to get like a full row of data. Yeah. And then it's doing this stuff again. Hmm. So use it, or maybe we could just put these in here. Does C have hoisting, or do you have to put stuff in order? Put stuff in order. Oh, I'm going to put new lines. I don't think this will work though, right? Because this is still calling these and they don't exist. Oh, it made them. Okay. Interesting. I wonder if it did it correct. I guess we could only import NumPy inside dither. It would save the requirement if you're not actually using it. All right, so we have Blinka loaded in source 1. We dithered that into bitmap. I presume it doesn't work. That doesn't have shape. Into string. Indices must be into string. Oh. But yeah, I think that's what it was talking about with algorithm info. It, I think, has refactored this some because... So basically, it's expecting this whole dictionary, which has all of these, but the C code doesn't take a whole dictionary. It just gets the constant, right? The constant that says it's either Floyd Stenberg. I'm going to try to do that correctly now that I know. I guess I still haven't heard a pronunciation, but probably not Stein. Algorithm. Okay, yeah. I think that's pulling data out of that somehow. Somehow we need to figure out how to do those so that we don't have to pass a dictionary. Instead, we can pass the constant. But I think I'm going to wrap it up for now. So thank you to everyone for hanging out, for watching along. Hope you all have a good rest of your day and a good weekend. I should be back at the normal time next week, 10 a.m. Central Time on Saturday. In the longer term, for the next couple of months, I may end up shifting my stream to be at a different time, so it might be something other than 10 a.m. Saturday. I'll make sure to announce it here before I do. But I think at some point I will get tired of doing deep dives on Friday night and then my stream on Saturday morning. After a couple of weeks or months of that, it does start to wear a bit. So I might shift to Sundays, or I might go to the afternoon, or I might do something. I don't know. I'm still trying to figure it out, but here's a heads up for that when it does happen. And otherwise, I will just bid you farewell. Thanks for watching along, and I'll see you later.